Good morning, dear students. Welcome to this session on pre-stressed concrete. We are solving for Unit 2 uh, and we are using the load balancing concept to analyze the given section. Let us proceed for the example problem solutions because last session we have talked about this concept, load balancing concept. So to balance the external loads, which type of uh, cable profile is to be followed and how that cable profile is going to resist is being presented to you in the last session. So now in this session, let us apply this concept to some examples. So let us see this one. A rectangular pre-stressed beam 150 mm wide, 300 mm deep is used over an effective span of 10 meters. So the span of the beam is 10 meters. Cable with zero eccentricity at the supports and linearly varying to 50 mm at the center carries an effective pre-stressing force of 500 kilonewton. Okay, so cable is having linear variation, something like this. Okay, if you draw it some scale, if you take this as midpoint, so it has got some eccentricity at center and zero at supports, just joined by straight line. Same here, zero at support. Zero in the sense the midpoint of the cross section. It has to join with the midpoint of the cross section. Okay, so that's how the cable is like a triangular shape. Okay, so just join by straight. This is what is now this being the CG of the concrete. So this is 50 mm here and 0 here. Okay, that is what is given. And force P is given 500 kilonewton. Find the magnitude of the concentrated load Q located at the center of the span. So this is the best suitable cable profile for point load at center, right? You know that. So find that value of Q. Have to solve for Q value for the following cases. So if the load counteracts the bending effect of pre-stressing force, neglecting self weight of the beam. Okay, if the load counteracts bending effect of the pre-stressing force only. Okay, then what will be the p value? I mean q value. What load it can resist? Okay, right. So what is the value of q when you don't have self weight and when you don't have external loads and all? Only pre-stressing force. That means at transfer, what you can say at transfer. That situation, what you say is at transfer. Okay. Right. So let us see how we solve for the case A. And case B is like if the pressure line passes through the upper kern of the section under the action of the external load, self weight, and pre-stress. What is a Q value? Okay. Upper kern of the section in the sense what like If the resultant stress diagram, if you see, the resultant stress diagram has got three possibilities. I told you that one possibility is that you can have tensile stresses develop, or you can have exactly zero stress at bottom, or complete positive may be possible. Okay, so these are the three options, and this option will give you the possibility of working for kern of the cross section. So uh, the pre-stressing force, whatever pre-stressing force that you apply, will create this situation. Okay, the in that case, if you locate the CG of the pressure line, okay, whether it is like this or somewhere else, so that location is the upper kern point. Okay, same situation is for lower kern point also. You can work out that the top stresses being zero and bottom you shall have the stresses. Okay, so that is how you have to work out for this kern points. Okay, so if you know the load, whatever you apply the load, so that load shall be just sufficient to balance the tensile stresses at bottom. So in that case, the location of pressure line is nothing but the kern point. Okay. So that way you have to understand that one, right? So the other way, the condition for the kern point is that the bottom fiber stress shall be zero. That way also you can understand, right? Okay, right. So proceed for the solution. So the cross section area, whatever is given, it is like 150 mm by 300 mm. So we get the cross sectional area, and Z value, which is BH square by 6, that will be 225 into 10 power 4 mm cube, right? Then self weight of the beam to be calculated by just cross sectional area multiplied by the gamma of concrete. And be careful with the substitution here. You shall be substituting in meters. The cross sectional dimensions, like 150 mm convert to meters, 300 mm convert to meters. Okay, and substitute, you get this gamma value in terms of kilonewton per meter, I mean self weight of the beam. Okay, and the load value given to you, and the eccentricity given to you, 50 mm at center. Okay, right. If the inclination of the cable to the horizontal is taken as theta, okay, so you have to balance the q value with the exact reactions that are being developed at the uh, developed due to pre-stressing only, right? So you have to calculate Q for such case. Okay, so to get the reaction value from this force, this is a force line where force is acting along this line. Okay, right, along this line. So you have to get the reaction value at this point, both from this part of the cable and also this part of the cable. So there are two such forces acting vertically, two components. So those two components, if you want, you shall be working out like components of a force. So this is theta. So horizontal component is cos theta, vertical component is sin theta. So there is vertical component called 2p sin theta. So that is equal to, there are two such things. So 2 times p sine theta shall be equal to the q value. Okay. So that is what is given here. Q is equal to, the load shall be balanced by the reaction components of the pre-stressing cable, right? So those reaction components are p sine theta actually. There are two such reactions, so 2 times p sine theta. And for the very small angles, because you have a very large span and the eccentricity is only in mm, 50 mm in a length of 5 meters or 10 meters, will create a very small angle. That's why for small angles, you can replace sine theta by tan theta. Sine theta is equal to approximately equal to tan theta. So why tan theta is required? Because when you write tan theta, it is like opposite side is E. So tan theta, if you write E divided by is L by 2 adjacent span. Okay, this is L by 2, this is E by L by 2. Okay, so that is what is written here. So 2 times P is 500 kilonewton. Okay, and tan theta replaced by E, that is 50 mm, by L by 2. L is 10 meters. You can see the span is 10 meters here. So L by 2 5 meters. Substitute in terms of mm, because this is in mm. This shall be in mm. Okay. So what you get is 10 kilonewtons is the load that is possible for resisting by the pre-stressing force alone. Okay. Right. That is answer for question A. If the load counteracts the bending effect of the pre-stressing force only, what is the value of Q? Okay. Then now second question. If the pressure line pass through the upper kern of the section, means what? Upper kern, if the pressure line pass through this point, the bottom stress shall be 0. Okay, that is a condition. So under the action of external load, self weight and pre-stress, what is the Q value, right? Let us see. So first find out the bottom fiber stress and equate that to 0, then you will get Q value, right? That is the logic. So moment due to self weight, like WL square by 8. So self weight we have calculated it 1.08. So WL square, L is 10 meters by 8, it becomes 0.125. So that is 13.5 kilonewton meter. And stress due to self weight is M by Z value, will give you this value, M by Z. Okay. So bending moment convert to Newton mm. Z is already in mm cube, right? Now stress due to pre-stressing, this is stress due to self weight. Stress due to pre-stressing is like P by A plus PE by Z, bottom stress at bottom. Okay, so you have to use plus here. P by cross sectional area, P into center section we are working out, so 50 mm is the eccentricity by Z. So that is around stress at bottom 22.22. Okay, is the stress value. Right now, if Q is the concentrated load at center, what is the stress from live load? This is like live load, right? So point load is live load now. So WL by 4 is the bending moment at center for a point load. Okay, you have a point load at center. What is the maximum bending moment? WL by 4. W is Q, which is unknown value. You have to find Q value. What is the Q value? WL by 4 is this one, and the stress due to that is M by Z. This is M value in kilonewton meter. Now convert that into Newton mm. That will be by Z. Okay, so now apply the condition that if the pressure line pass through upper kern section, stress at bottom shall be 0. So that means you write the formula for stress at bottom like P by A plus PE by Z minus mg by Z minus mq by z. Okay, that shall be equal to 0, right? Our condition is it shall be equal to 0. Means what? This shall be equal to this minus, if you take it to the right hand side, will become plus. So that is equal to, this will become, this will go to the right hand side, which is mg by z and plus mq by z. Okay, right? Okay, so left hand side you have m q by z is this value, and mg by z is already there. 6 is the stress due to self weight, and this is due to live load, which is a point load, which is equal to the stress due to pre-stressing force, that is equal to 0. That is p by a plus pe by z. What is p by a plus pe by z value? It is 22.22 total value. Okay, right? So this is total p by a plus pe by z value, and this is mg mq by z, and this is mg by z. From this you get q value, that is 14.6 kilonewton. So when you have a live load of value q, so it can resist a load of 14.6 kilonewton, right? And if you have only the pre-stress alone, so the load that it can resist is 10 kilonewtons. Okay, so when you have live load and dead loads, the q value is maximum that you can apply is 14.6 for a condition that bottom stresses are 0. Okay, so this is what is the way that you answer. Okay, so load balancing. So to balance the load q, what shall be the pre-stressing force? That is actually the real life problems. We know the load, and how much pre-stressing force to be applied is a real life problem. Here it is given in a reverse order, that you have been given p value, pre-stressing force is given to you, and what load it can resist. Okay, for the two different cases, right? Okay, right, done. Maybe next session we will discuss this other some other example problems, right? To practice this one along with the concept that we have discussed earlier, right? Okay, thank you.